Number 3, let's find the third order Taylor polynomial for function f, the natural log of x, centered at 1. All right, I noticed students do this 3 different ways. The way I would have liked to have seen you do it is through memorization, because you may recall, I let you know that there are 4 fundamental functions for which we should memorize the Taylor polynomial: cosine x, sine of x, 1 over 1 plus x, and the natural log of x.
This is the Taylor series for the natural log of x centered at 1. This is the general form, and this is the interval of convergence. And all this information should be committed to memory. And when it is, coming up with a third-degree Taylor polynomial is as easy as writing down the first 3 terms. However, quite a few of you did not have this series memorized, in which case you have one of 2 options, both of which ate up a lot of your time. First option is to generate the Taylor series from scratch. We'll need to go from n equals 0 to n equals 3 to get the third degree polynomial. And the formula is the nth order derivative at where we are centering it times x minus where we're centering it to the nth power over n factorial. So if f of 0 order of x is just ln of x, the first derivative is 1 over x, the second derivative and the third derivative are as such. And when we substitute a 1 in for each of these, we get 0, 1, negative 1, and 2. All right, now generating the Taylor polynomial with the formula. When n is equal to 0, we have f of 1 times something raised to the 0 power, which is 1 over 0 factorial, which is 1, so just f of 1. When n is equal to 1, we have the first derivative at 1, which is 1, times x minus 1 to the 1 over 1 factorial. When n is equal to 2, we have the second derivative at 1, which is negative 1, times x minus 1 squared over 2 factorial. And when x is 3, we have the third derivative at 1, which is 2 times x minus 1 cubed over 3 factorial. Now this 3 factorial, the 1 times 2 cancels out with 2, leaving us with just 3. And we get what we had here. A lot of time, though, when this should be memorized. What was the third thing some people did? Some people went through all the trouble to do some really nice math, but a waste of time. They realized that the derivative of f of x was 1 over x, which can be rewritten as 1 over 1 minus x, which can be rewritten this way so that we can see that it's centered at 1. And now we recognize this as the sum of the converging infinite geometric series whose first term is 1 and whose common ratio is what's in the brackets. Therefore we can generate the first couple of terms. The first term is 1, and then you multiply that by the negative 1 times x minus 1. Then you multiply that by the negative 1 times x minus 1 again. And it goes on, but since this is f prime, we need the series for f, so we'll take the integral of that. And taking the antiderivative of each term here, we get these terms. Now be careful, the antiderivative of 1, some people were tempted to say just x, because the antiderivative of 1 is x. However, we are in the form of x minus 1. We are centered at 1. So if you're centered at 1, it's not just going to be x, it's going to be x minus 1. Notice that the derivative of x minus 1 is still it's still 1, like it's supposed to be here. All right, and then if x is equal to 1, f of x is the natural log of 1, which is 0, equals 0 minus 0 plus 0. So c is 0, and therefore we don't need to write it. And there's the answer. The most complex way, when you should have memorized it, but that will do. And that's an explanation of how you could have gotten the correct answer doing it this way. All right. hope this all helped. Let's move on to part B.